So welcome everyone. This will be the last Forever Green Lab discussion for this semester. We'll start again on September 10th this fall. And I'd like to ask everyone to send me some notes over the summer as to your feelings about the lab meetings, and if you have some additional ideas as to what you would like to have presented in the lab meetings that will be coming up in the fall and spring of 21 and 22. So all feedback is welcome, and it will be taken into consideration to make sure that we keep these lab meetings current and meeting the needs of everyone that's in attendance. So over the semesters, we've had, in a range of 35 to 75 people participating each week. So I think it's been useful to a number of folks. And I plan on continuing to hold these discussions. But we'd certainly like to have feedback from each and every one of you to give us an idea of some of your ideas as to how we can continue to make these sessions as useful as possible. So today, Julie, you're not full screen yet. It's still not full screen.
Let's see.
Can you just click switch displays? Oh, yeah.
Okay. Let's see.
So on your top, yeah, switch, yeah.
So I was trying to get it so I could still see everyone while I was presenting. Let's see.
You have two screens or just one?
I have two, so I was going to try to put my presentation on the one and keep the chat up and the...
Yeah, normally when you are presenting, you probably wouldn't be able to see anyone.
Oh, well, something happened and it worked, so.
Oh, okay.
Right.
You're fine. So today with Julie Cubins will presenting, and she presented her APS thesis proposal. And I thought that some of the ideas and concepts that she presented there, more of you needed to hear it. So I invited Julia to present today, and looking forward to the presentation. Like I say, Julie, I apologize for shipping back and forth, but I'll basically turn it over to you, Julie.
All right, that sounds great. And I feel honored to have my own time slot when everyone else has to share with a bunch of other people. So this will be somewhat similar to what my seminar was in the fall for the APS seminar, with a little bit of data added in for flavor. And I think so that this isn't just a giant monologue of me talking. If you have any questions or comments during, just feel free to jump in. I have the chat up too, so if you type anything, I will look at it periodically to try to break things up a little bit. But yeah, feel free to jump in if you have anything that you want to add. So I'm going to be talking about two of my projects for my PhD, which are very different from each other, but I have been enjoying working on them both. And I also have my window partially open because it gets really hot in here without any airflow. So if it gets too noisy, let me know and I can close that. But I will get started. So just to jump right in, I am working with Camelina. And one of the challenges of working with Camelina is that it has really small seeds. So it doesn't establish well in a high residue environment. And as I think most of us on the call know, corn leaves a lot of residue, what we call stover, on the ground after harvest, which can make it really difficult to incorporate something like Camelina as a double crop into the corn soybean rotation, specifically after corn in this case. So one solution for that is to remove corn stover from plots before planting Camelina. And this kind of brings me into, I thought I had another slide, but this kind of brings me into my agronomic objectives. Hold on, I might jump around a little bit because I think I'm missing something. I'll come back to it if I find it. Okay. So the agronomic objectives of this project are to assess the yield potential, as I was hinting at, of a corn, camelina, soybean rotation, utilizing short season corn hybrids so that we can actually get that camelina planted and germinated before the winter. And so some hypotheses for this study are that a short season corn hybrid will yield less than the full season hybrid, that camelina will establish more successfully following a short season hybrid than a full season corn hybrid due to the fall growing degree day availability, and that soybeans relay cropped into camelina will develop fewer pods than soybeans planted into a fallow plot. And then another hypothesis for this is that overall treatments with good camelina establishment will have the highest overall seed yield for the system. And then I have a second agronomic objective for this study, which is to evaluate camelina establishment in environments with and without corn stover. And I hypothesized that camelina would be more successful in a plot where the corn stover is removed as opposed to where it is remaining on the ground. And so the general design for this experiment is that it was run over the 2019-2020 growing season at 2 sites, one up at the USDA in Morris, and then one down at the Research and Outreach Center in Rosemount. Randomized complete block design, 4 replications, and this research was funded by the Walton Family Foundation. So as far as experimental design goes, we had 4 blocks of corn, 2 blocks of 82-day corn, 1 of 90-day corn, and 1 of 95-day corn to kind of represent the full season corn hybrid that might typically be used. All of these corn hybrids were planted at the 2 locations in early May 2019 at about 35,000 seeds per acre. And so we didn't really do anything over the time that the corn was growing, fertilized it, make sure that there weren't any crazy weeds in there. But other than that, just let it grow. The corn was then harvested based on when it was ready to be harvested, which was dictated by that hybrid relative maturity. So the 82-day corn in both locations was ready at the end of September, 90-day corn beginning of October, 95-day corn mid-October. And so this also represented our camelina planting dates. But before I get to that, we also had that stover removal component. So within each corn block, there was one plot where the stover stayed on the corn, just as you would have in a grain corn system, and then another block where the stover was removed, that kind of represents a silage corn system. And then we would go through and plant camelina into it. And so here are just some visual representations of what that looked like in the field. This was in Rosemount after that 82-day corn at the end of September. On the left-hand side is the plot where we left the stover on. You can see that there is a lot of material on there, and see how it might be difficult to plant camelina or anything into that and have it germinate successfully. On the right-hand side is where the stover was removed, a much more friendly seed bed for camelina to be planted into. And then this is what it looked like at Morris. It does look a little different. So in the middle, we have that stover removal plot. That's actually 2 plots next to each other. And then on the outsides, you can see where the stover remained on. The stover wasn't harvested as high at Morris. It was harvested pretty low, or the corn was harvested pretty low. So there's a little less plant material on the ground. And from a data collection standpoint, one oversight in this project was that we did not take corn stover measurements, the volume that was left on the ground, which is obviously a huge factor in this project. And so one way that I'm trying to remedy that is that this same project was completed in Pennycrest the year after, and it had the same corn hybrids. And so we'll use it as kind of a reciprocal example of how much corn stover is left on those plots to try and get at those numbers and just see what that volume of material we're trying to plant the camelina into. And so the corn, it yielded pretty much as expected. The 82-day corn yielded the least prolifically, and then the 95-day corn yielded the most. And as we do often see at Morris and Rosemount, the Rosemount yields are a little bit higher due to the slightly longer growing season, slightly different conditions. And you may be looking at this and wondering, hey, Julia, why is the 82-day corn at Morris, why did that yield so low? That's because we had some friendly bird visitors. They really decimated the corn kernels and ate them up. So it looks at just visually about 50% of the corn was eaten by birds. And if we look back at this plot, that seems, about right, considering what the yield could be. Just looking at the other plots as well, or the other treatments as well. So unfortunately, we had a lot of bird damage, which messes with the data, quite a bit, but also represents a very real world scenario that might happen in an agronomic setting. And so after we harvested corn, removed that stover or kept it on, camelina was planted. And this was part of the reason we had these two 82-day corn blocks, because one of them acted as a control. And so even though the 95-day corn would be the typical full season, we really wanted to compare what it would look like with the control, considering our previous knowledge about camelina. The earlier we can establish it, the better it's probably going to do, just because it has more time to grow before we have a frost. And so those camelina planting dates just coincided with the corn harvest dates. And so similar to the corn harvest, we have a camelina planting date, late September in the 82-day corn, early October in the 90-day corn, and mid-October in that 95-day corn. And then those control plots that act as kind of a grain corn control and a silage corn control of what we might see as kind of a best management practice. And so in order to determine how the camelina was doing, especially in these environments that may not be the best suited for camelina production, I took establishment measures about 2 weeks after the final camelina planting date. So I think it was the first week of November. And one question I've gotten in the past, especially for this picture, is what is all that white stuff on the ground? It is not fertilizer, it's actually snow. I had the bad luck of having it snow pellets on the day we were out there taking these measurements. And so in order to take these measurements, I took canopy cover data using Canopio, the app, and then also populations within a 1 meter length of the plot. And so I was really relieved to find that the snow didn't interfere too much with the Canopio data. There are obviously these little dots around, but it's very clear what's snow, what's plant material, and it didn't really contribute to canopy cover numbers at all. And unfortunately, the camelina didn't establish that well. This was the best camelina plot by far, and it was planted in that first planting date following the 82-day corn with the stover removal. So really best case scenario for the camelina. And it only had about 1.7% cover according to the Canopio app. Most of the other plots had much less, even 0% cover. I think a lot of them were around 0.02. I was just looking at it yesterday. So it didn't look great. And if we look at that data, so this has the ground cover data. This is just the Rosemount data. The fall is grouped on the left between those 3 corn relative maturities, and on the right-hand side is the spring data, again parsed out by those 3 corn relative maturities. And as you can see, even in the spring when I took these measurements, the highest percentage for that camelina data was only about 6%, and that in the 82-day corn, there's not a huge difference between, especially in the fall, but in the spring, we can see the ground cover really taking off compared to the 90-day, the camelina in the 90 and 95-day corn plots. And this is even more evident if we then look at it split up between the stover removed and the stover kept on plots. So on the left side, we have that stover removed, no stover on the plot, and then the stover remaining on the plot. And in between the fall and the spring of the no stover, you can really see that Camelina in the 82-day corn take off compared to the Camelina in the 90 to 95-day cover. But then again, as I was mentioning, 6% ground cover isn't great, but considering that this was taken at the end of April, I think the Camelina was doing all right. And then just looking at the stover plots, the Camelina was not doing very well comparatively, which would be expected considering that it was being planted in circumstances that were not at all ideal for Camelina planting. And just to give kind of a visual, extra visual representation of this, these were two plots. These are both 82-day corn plots. So the left is the Camelina that was planted into corn stover. The right is the Camelina that was planted without the corn stover. Basically, the most ideal circumstances for Camelina within this study. And the plots on the right look pretty good. This was taken, I believe, the end of April, around the same time as those establishment measurements. And the plot on the left, there is Camelina there, but it's pretty patchy. It didn't emerge very evenly. I would say emergence was not great, or it was fair, maybe we would say. But there really was a big difference between the plots with stover and the plots without stover, just really emphasizing that Camelina needs some clear soil in order to germinate successfully. And this is just another picture illustrating this a little bit later in the season when the Camelina was just about to start bolting. This is the same two plots on kind of the left-hand side of the screen is that stover plot, and you can still see how patchy it is. I think it's maybe even more emphasized here with a little bit more sunlight and the plants are a little bit bigger. And then on the right-hand side, you can see that plot where the stover was removed. And so what did this mean for Camelina yield? So I only have the Morris data for this right now. It's still getting kind of processed right now. So it's kind of as you would expect within each corn treatment. The stover, the plots that had stover, the Camelina yielded much less than the plots that had the stover removed. And as we would also expect with each later successive planting date, the Camelina yield also is reduced, likely because of that lack of establishment in the fall before winter started. So this really shows that the Camelina without stover planted early, as I've said a number of times, that's really the best case scenario for Camelina under these circumstances. And that would be, the equivalent maybe to planting Camelina just by itself on its own plat without any double crop action in there. And so before the Camelina bolted, around the time when that last picture was taken, soybean was no-till drilled into the plots. So we waited until the Camelina was big enough that it wouldn't be outcompeted by the soybean right when it was planted, but not so big that the Camelina was bolting and would be crushed by the planter. So at Morris, the Camelina was planted on the same day in all treatments, May 7th, 2020. And at Rosemount, the first two corn relative maturities had the soybean planted into them on May 8th. We waited a little bit longer for that 95-day corn treatment just because the Camelina was so small and so patchy. We wanted to give it a little bit more time to establish and not totally be outcompeted by the soybeans. And here's just some pictures of soybeans in the Camelina. It's kind of hard to get pictures of green on green, but you can see this is around the Camelina. The seed set is setting, and the soybeans are looking pretty happy considering the canopy cover that they're under and the competition between two crops. the soybean looks pretty good. And so as far as soybean yields, this was also just the Morris data. As you might expect, the soybeans did the best in the plot with no camelina in it, so this 82-day check. And then it performed fairly similarly across the other treatments. I thought it was really interesting that it performed better under the treatments with stover than the treatments without stover. So like in those plots, there would have been camelina. I'll get to that question in just a second. There would have been camelina and stover along with the soybean in the plot. And I just found that interesting and kind of counterintuitive to what I would have expected. And so David Marks is asking, how do your results and methodology compare with similar studies by Winfippen and Covercress with pennycress? So this is the exact same study as in a pennycress study. So there's another corn relative maturity by pennycress. This was deployed in 2019. The pennycress study was deployed in 2020. So as far as methodology for that, this is exactly the same. We're taking the same measurements. The only thing that's different is if it's pennycress or camelina. And so that's currently in the pennycress phase right now. As far as other studies, I am not sure, but I know at least for the I prefer group, this is the same thing as they're doing for the corn, oilseed, soybean system. So hopefully that answers that question. So this kind of concludes the agronomic objectives of this study. Unsurprisingly, the corn yield was highest in the 95 relative maturity treatment. The soybean yield didn't vary much across camelina treatments, but it was highest in the check plot, as we would expect, given that it would have nothing to compete with except for stover in one of them and nothing in the other. And camelina did perform best in plots where stover was removed and when it was planted earlier. So this really does reinforce those hypotheses that I was considering at the beginning of this study. So I guess that's good. But in addition to this, there is an environmental objective going along with it, not just this agronomic piece. So when we're thinking about stover removal, there are negative consequences to that. So when you don't have anything on the soil, as I think we're very familiar with in the Forever Green group of crops, your soil is more susceptible to erosion. And there is also evidence that yield of your subsequent crops may decline, either due to that soil erosion or loss of soil carbon, which is huge in this when you're considering moving stover, since usually there is quite a bit of plant material that is returned to the soil. So that soil organic carbon decrease is associated with degraded soil structure, decreased aeration and water damage, and just a decrease in nutrient holding capacity of the soil in general. So this can have some pretty big unintended consequences. But there has been research to suggest that winter crops, like the oilseeds we're working on, may supplement soil organic carbon and offset those losses due to stover removal. So there were studies that considered cover crops specifically in both continuous corn and corn soybean systems, and that those were able to reduce the impact of stover removal. But research hasn't been conducted to determine whether the winter oilseeds we're working on can provide the same benefits. So with that, I had a few environmental objectives for the study. The first was to assess nitrogen and phosphorus retention in the soil to see if we were losing those nutrients, especially in the areas where we didn't have any vegetation, where that stover was removed over the winter, or where the camelina plants were really, really small, maybe too small for the roots to really physically lock in those nutrients or protect the soil surface with the vegetative cover. And so I hypothesized that the treatments with more ground cover would retain nutrients, more successfully. And then the second objective was to observe soil carbon dioxide efflux throughout the growing season. And I hypothesized that carbon dioxide loss would be minimized in plots with greater amounts of living ground cover. So in order to think about these objectives, to get some data for them, started by soil sampling. This occurred at 3 times over the course of the project. So the first one was after corn harvest, the second was at spring thaw, and then the third was at Camelina harvest. And we sampled at 3 depths in order to, get the different layers of the soil profile. And then those soils were tested for nitrogen, phosphorus, and total carbon. So I just actually got the data back for this yesterday, so I'm not going to show any of it because I really haven't gotten a chance to look at it yet and parse out that information for those different treatments. But if you're interested in talking about that, have some thoughts about it, circle back to me in a few weeks and I'd love to chat about it. And so then moving on to those CO2 efflux measurements, I measured this weekly from April, about mid-April through Camelina harvest. I actually went, I think it was just a week after, maybe 2 weeks after Camelina harvest into July to capture that whole period of Camelina growth and development and then harvest. And so for a couple reasons, I only sampled this in 3 of the treatments. So the first was in the grain corn kind of best management practice. The second was in the silage corn kind of simulated best management practice. And then the third was in that best case scenario, stover removed 82-day Camelina, 82-day corn Camelina treatment. And so this was for a few reasons. The first was time. You're supposed to take the measurements between 10 and 12 in the morning, try to get those all in. That often didn't happen. It often took me much longer, between 10 and 2 or even 10 and 3, to even just get these 3 treatments. It was only 4 reps, so 12 plots overall. So adding more was just not feasible to try and meet those time constraints. And then the second reason was that when we sat down and thought about what are we really trying to look at, what we're trying to look at is kind of, what's typical. So those grain corn and silage corn treatments. And then what's kind of the Camelina baseline using the best case scenario for Camelina. So that's what we looked at. And so I used a Lycor 6400 portable photosynthesis system. There it is in the field with me. It was my #1 field buddy this in 2020. Spent a lot of time together in the field. Lots of selfies with it. And there, within each of the plots that we looked at within those treatments, there were 2 PVC collars per plot. And basically there was just this chamber that I stuck on each of those PVC collars, and it would pump all the carbon dioxide out of that chamber and that PVC collar down to just below what the atmospheric CO2 was, and then measured how quickly it built back up in the chamber. And it did that a number of times on each collar, and then I would move to the next one. And so this data, I'm just going to show you the raw data. I haven't dove into this that deeply. This is, I think, the most out of my wheelhouse data that I collected in this project. And so I'm still trying to learn what these numbers mean, what is a significant difference between numbers, really just get a grasp on it before I dive in. But if we look at this, so it's by Julian date on the bottom, and then the CO2 efflux measurement on the y-axis, and they're just split between those 3 treatments, the one with the Camelina stover removed, the fallow plot, which was the stover removed, and then the plot that had the stover in it. So overall, the measurements were pretty similar early on for the first, 5, 6 sampling times. And then we started to see some differences. There were some pretty significant precipitation events, especially right before we see it increase. And so I think that had some impact driving that CO2 out of the ground just the water's filling up the pore spaces, so that makes sense. But similar to the soils data, hopefully I will be able to talk about this a little bit more intelligently, not so much of an educated guess over the next few weeks / months, I guess. And hopefully at that time I can talk about it again and have some more conclusive results to say about it. And so to kind of wrap up this section, carbon studies usually take multiple years, even a decade, to see any meaningful differences. So this study, which only took place over 2 growing seasons, isn't going to show us meaningful differences in the carbon in the soil, but it will give us a baseline for what these systems look like, the conventional corn systems, and then the corn, camelina, soybean rotation system, and just give us a baseline of what that looks like and hopefully be a jumping off point for multiple studies in the future. So no conclusions yet for this piece, but circle back in a bit and hopefully I'll have some things to add. And so now I'm going to take a pretty hard pivot to talk about one of my other projects. So I have these 2 big projects. I have one smaller one that I'm not going to be able to get to today. That's a pennycress project. But my second project really is looking at science communication and the methods by which we communicate science. And I think, as we're all familiar, one of the main ways is through scientific journals, manuscripts, papers, conferences, and I think we're somewhat lucky in the field of agriculture to have field days and get to really interface with farmers and other stakeholders. And I think that's different compared to a lot of other fields. But I think that there is a huge gap, and it's not just me that thinks that. There is a huge gap between the knowledge that we're generating in the academic world and the information that gets out to the general public and a general audience. So that can be kind of difficult because in academia, I think, again, as we know, there isn't a lot of reward for communicating science outside of these conventionally accepted methods. And so how can we balance the research we're doing with the education and the learning components that I think a lot of people are becoming more interested in? And so online programming is becoming a more popular way to reach broad audiences. I mean, this includes things that I think a lot of people in agricultural fields are already doing, like extension bulletins, and now in the pandemic, having online field days in addition to the in-person field days. There's a lot of different ways online to reach the audiences that we already kind of focus on, but then also ones that we are interested in adding to our repertoire. And so one way to do this is through podcasting, which is an on-demand tool, or a tool to produce on-demand media. It can also be an on-demand tool. And for those of you who are not as familiar, this was developed in 2004 as a way to automatically download MP3 files, so people didn't have to go on the internet and manually download everything as soon as a new episode or just new whatever clip someone is uploading is available. It would be automatically downloaded. And it's not an Apple invention, but it is a portmanteau of iPod and broadcasting. So then we come up with podcasting. And so one of the benefits of podcasts is they can be I need to drink some water. They can be played and replayed at the listener's convenience, which makes it a good way to use it as an educational tool. And podcasts have actually been used as a science education tool for a while now. Most of the literature surrounding podcasts is using it as a review tool in higher education, and there is quite a bit of general education happening in the medical field with podcasting. So there is some precedent for this, but there isn't a lot of research about it. And so in order to think about this, think about, is podcasting a good way for us to present our research to audiences we don't normally reach, people that aren't in our field, other scientists, and just a general audience? Can this be a good way to help people learn about what we're doing? So there are 4 phases to this project. The first was to create and host a podcast. It's this Hooked on Science on the bottom. The second was to determine study hypotheses and create a listener survey. And the third was to distribute that survey and collect data from listeners. And then the fourth, to hold follow-up interviews. So I am kind of split between phases 1 and 2 of this project at this point. I have been taking my time on it since this is a social science project. This is not in my wheelhouse. I'm doing a lot of things that aren't in my wheelhouse in my PhD, and I think that's been really great for building skills for myself. But also I want to take my time and learn with the time that I have. So in this first step of creating and hosting a podcast, I made a decision for myself that I wanted this to be a general science podcast. I didn't want to be limited to a narrow subject area, and I wanted to learn about topics that listeners find relatable. And for myself, I just thought it would be really interesting to have an opportunity to learn about a lot of different things and not pigeonhole myself in one specific topic area, and be able to kind of jump around and just see what was interesting at the time. And so there's a lot that goes into creating, hosting a podcast. Here's me post-recording an episode. The first is to recruit guests, and I've done this through a number of ways. A lot of it's through word of mouth. At the beginning, it was people that I knew I would have on the show just for a comfort level of something that I was doing that was totally new to me, and I wanted it to not be so big and scary, but be talking with people that I was already familiar with. And since then, it has evolved to word of mouth, where friends of friends will, either volunteer themselves for the show, or someone will suggest another person for the show. And that's been a really great way to get new topic areas integrated into the show. And then I've also started cold direct messaging people on Twitter, which has been shockingly effective. Just when I see people posting interesting things, I will send them a message, and that's been a good way to recruit guests as well. And so the next step is to build the episode. I work with my guests through email to talk about what they want to talk about in the episode and exchange materials, what they need to know before we record, usually like a poster or something that they send me to help generate questions. And so for that, I prepare for the interview. I usually have a loose list of questions, but I really try to keep it conversational and just go with the flow of what they're talking about, which has really helped me work on my active listening skills so that I can try to create the best flow in an episode as possible. Then we record the interview. We do this all online. There's a free program that I use. It's not even a program, it's just a website. It's called Zencastr. It's a great way to record remote interviews. It was specifically made for podcasting. And then I don't think most people do this, but I create and edit a transcript so that when I go into the audio, if I move anything around, if there's anything I need to add that I'm talking about or that the guest is talking about and I need to kind of break it up, this helps me figure that out before I even dive into the audio. Then I edit it. This is the longest part of the process. It usually takes me 5 or 6 hours per episode to do this, but I like it to be exactly the way I want it before I release it to the world, because it goes on the internet, it's there forever. I want it to be a good representation of both myself and the guest. I always tell them that my job is to make us both sound smart. So I try to do that the best that I can. And then I upload the episode for distribution. I have a host that distributes it to Apple Podcasts, Spotify, Google Podcasts, Stitcher, all the big podcast places, and many of the small ones, so people that can listen to it. And then finally, I manage social media accounts for the podcast. So overall, I wear a lot of hats in this project. I am the recruiter, the editor, the host, the producer, the social media manager. It really has me working in a lot of different areas that I honestly never thought that I would be doing work in. And so that brings me to kind of phase 2. So this is where I'm at now, which is creating the listener survey. And it was really important to me to make this not specific to my podcast. And the main reason is because I don't have a ton of listeners. I'm happy with where my podcast is at, about 1,950 downloads right now, but I didn't want to, limit myself to just the people listening to my show, and then even further, the people that would actually answer the survey. So I'm making the podcast general or the survey general enough that it can be used, distributed by other science podcasts, and those are connections that I've been building in this process. And so this listener survey is really centered around 4 hypotheses. The first is about trustworthiness. Listeners believe that the guest and host are trustworthy sources for information. This is, really the crux of this study. So that was really important to get in there. I have another hypothesis centered around this, that a podcast can provide more trustworthy information over other Web 2.0 information sources. And by Web 2.0, that's like social media, YouTube, Facebook, that kind of stuff, where there is a lot of misinformation. But again, podcasts, anyone can make a podcast and say whatever they want on the internet. So this is pretty subjective, depending on what information sources you're considering. And then my third hypothesis is considering convenience. Listeners believe that podcasts are a convenient way to learn. This has been somewhat established in the literature already, but I do want to kind of reinforce that. Then there's also an accessibility component, as in podcasts communicate information in a way that is easy to understand, which is really important, especially when we're translating scientific information to a general audience who might not have any knowledge of those topic areas. And so I'll collect this survey data, this quantitative data. I'll take some demographic information questions. I already have some information about this just from my podcast host. It's owned by Spotify, so I get some data just of my Spotify listeners, gender, age. And this age graph lines up really nicely with the research that's done. There's this group that called the Infinite Dial that does a podcast survey every year, usually a couple thousand people. And so my age group is really captured in that 25 to 34 age group. If you compare these two graphs, that the one of my podcast and the one that they put out on the right-hand side. And I also like to keep an eye on where people are listening from. So I have listeners across the US. Minnesota is a big hotspot, unsurprisingly, but also Georgia and Washington. And then I have listeners among other states as well. One of my goals for 2021 is to have just someone listen in every state. So if you are taking a trip out to any of these states that are in this light blue color, the white light blue color, give it a listen so I can meet my goals for the year. And then in addition to in the US, I have listeners across the world. The US makes up about 90% of my listenership, and then 10% from these other countries. As you can see, quite a bit in Europe, and then some scattered throughout the rest of the world as well. And so getting back to that quantitative survey, those hypothesis-driven questions will utilize a 5-point Likert scale, which is that strongly agree, neutral, disagree, strongly disagree scale. There's a lot of precedent for that to translate subjective data into a quantitative method. And I will be collaborating with other podcasts with similar educational objectives to get the survey out. As I mentioned earlier, I don't want this survey to be specific to my podcast, though I will probably have a checkbox to get an idea of the people listening to my podcast and have kind of a subset of data that's just my podcast, and then the whole pool altogether. And so this is in development, and I will deploy it using Qualtrics, hopefully in June. Depends on how quickly IRB turns that around. And then I'm hoping to put out episodes every week during this time to try to get that survey information out. I'm also on the podcast circuit myself. I've done a couple episodes with other groups that will be coming out in the next few weeks. So that's a lot of fun. One is about, it's called You Can Grad School, and it's just about life in grad school. And we talked about science communication. And then I'll be doing an episode with Planthropology, which is a plant science podcast. So that is fun for me. And then after the quantitative data has been collected, I'll be doing some qualitative surveys. And these questions will be developed after the quantitative data has been collected. This will consist of face-to-face interviews over Zoom to gain better insight into findings of the initial survey, get some nice quotable blurbs for my manuscript. And obviously participation is voluntary. People will have the opportunity to give me their contact information if they want to participate when they take that initial survey. And that these interviews will be conducted in August. And so there are a number of challenges to podcast production. From a science communication standpoint, one-way content creation is not ideal like what we have in a podcast. I am talking with someone and then I'm uploading that information, and I don't have a lot of back and forth with listeners because of that. They don't have much of a say in what happens during the interview process, though I have created a sheet or a Google form that after the fact, if people have questions, they can answer them. They're also welcome to submit guests recommendations if they want to be a guest. I really want to get people involved in this project so that they feel like they're a part of it and it's not just me shouting into the internet void at them. One of the other challenges is that creating content is a lot of work. So creating content isn't for everyone. As I mentioned, there's a lot of steps to this, and it is kind of a hamster wheel that you get on and it just keeps going and going and going. But it's very rewarding at the same time. And I think the biggest thing, especially going into survey season, is that building an audience is hard. I have been kind of pushing off doing my survey because I want to try to build the largest audience that I can within my podcast before I put that survey out. But that can be difficult, especially since I'm not in a specific niche. I'm just talking about science generally. And yeah, that kind of comes into this, not having a niche to cater to. It's harder to publicize your podcast on specific platforms if you're not talking about something specific. But to end on a more positive note, there are a ton of benefits to doing this. It's an easy way to get research and other information into the world. Podcasting is free. If you have a smartphone, you can produce an entire podcast. You don't need any other equipment. All of the tools I use are free. I use GarageBand to edit. That comes standard on Macs at least. And I use Anchor as my host, which is free. And social media is free as well. So can be really straightforward, and it doesn't have to be complicated. And it can be a good way to get research and other information to new audiences. And I found that it's a good way to build my network, not just in a professional sense, but in the sense that this year has been a time of isolation, and I have been able to carve out an hour and a half to talk with new people who are excited to talk about their research and excited to, socialize a little bit. And so it's been a really nice way to expand both my skill set and my knowledge of other disciplines. And there's a huge group of science podcasters, science communicators, and it's been nice to tap into a group of really engaging and really enthusiastic science communicators and just see what they're doing, learn from them, chat with them, and get new ideas. And podcasting, although it is a one-way form of communication and there are some major challenges to that, it's allowed me to build a rapport with an audience that's interested in science. So as I mentioned, people have suggested topics, guests. They can have that two-way communication where they ask questions if they have a question about a past episode. And so just kind of like building a rapport and that trustworthiness. I've had guests come on who I asked all my guests to listen to an episode or two before we record to get an idea. And I've had people come on and say, oh, like, I feel like I already, have been chatting with you, know you. So it just makes things more comfortable when it comes time to record an episode. So even if, on the day-to-day, I don't know that it's there is evidence to suggest that I am building trustworthiness and just thoughts in general, or just a relationship in general with my audience. And then I really am in this project developing new skills that address some of my weaknesses as a scientist and human in general. It can be pretty nerve-wracking to go into an interview where you don't know the person. And so that has helped with some of my anxiety. It doesn't mean that, going into every episode is easy breezy, but it's helped me become more comfortable with that uncertainty. And then also, it's helped me work on my active listening skills. I'm not always the best auditory learner. And so I've had to work really hard to pay attention and make sure I understand what the guests are talking about so that we can have a flowing conversation rather than a stilted interview. And so I really enjoyed that. And so some of the frequently asked questions that maybe I can get ahead of is, how long will I keep doing the podcast? So my goal is to put out the podcast through the end of the survey and then take a hiatus so that I can work on my dissertation and work on crunching those numbers and just have some space, because podcasting does take up a lot of my time. It is a labor and time intensive thing. So as much as I've enjoyed it, I am looking forward to when I do take that hiatus and I don't have to worry about it for a bit. Another one that I hear a lot is, will I continue after I graduate? Maybe. I think I would either need a co-host or someone to help me edit, because I think having a full-time job and trying to do this would be extremely overwhelming, a little bit of a nightmare, maybe. As fun as it is, it, again, is very time-consuming. And another thing I hear is, how do I decide what topics to be featured? People request topics, people suggest guests. As I mentioned, just DM people on Twitter and see if they want to participate. And I just kind of go with what I'm interested in. I did put out a listener survey at the end of 2020 to get an idea of what people wanted to listen to. And that ranged from sociology to the plant sciences to mindfulness to all sorts of things. So I've just been jumping around and kind of going with what I feel will be interesting for listeners and interesting for myself. And one thing I just like to think about is, there are some top episode topics. And so my top 2 episodes have been in the health sciences. And I don't know if that's because I'm clueless about the health sciences. So I ask the questions that people are wondering about that don't know things about the health sciences. But also I've had my other top episodes have been in horticulture, ecology, production, agriculture. And so on that note, if you would like to be on the podcast or know someone who would be a great guest, I have this link. It's Linktree with the dot between the R and the E /HookedOnScience. And I take all requests. It makes my life easier, cuts out the guest recruiting aspect. And that would bring you to this landing page, and just click on suggest guests or topics, and there is a page there. And just to conclude, this is a constantly evolving project. I know that scientific research does not appeal to everyone, but I think that there is a listener base out there who would enjoy it. And overall, I hope that this project provides baseline information for research-based podcasts in the future, and that this podcast or the research that comes out of this podcast can serve as a model for a new way to adapt research for a general audience. And with that, that was my very long presentation, and I can take any questions if people have them.
Hey, Julia, this is Debbie Samick. I have a question about your app that you used for the cover, the Canopia. So did you do any work to see how well it correlated with your stand counts or biomass yield or anything like that?
Yeah, so at the same time, in both the fall and the spring, I took population measurements. And just looking at those numbers, I mean, it's kind of an estimated guess based on it. You know, plots with a population of X seem to have this % ground cover because the plants were all about the same size. And so I think, you know, as far as accuracy, I think this conversation comes up a lot. Maybe they're not the most accurate, but from like the relative plot to plot, thinking about that, they seem decently accurate. But they did correspond pretty well, those % cover numbers, with the populations that I saw in that same area.
Yeah, that's good to know. We're looking for some, you know, way to more easily count little alfalfa seedlings, you know, 10 days after or 30 days after planting. Do you suggest putting any kind of like a meter marker or anything down as well? Or do you just take a photo? You know?
Yeah, I think that they suggest taking it from a consistent height each time, and, you know, trying to get, not to get any shadow in there. So having the same person take it kind of keeps that consistent. But for me, I did put flags a meter apart, and then I did it 1 meter by the width of the corn row. So it was about 1 meter by 2.5 feet. And that kept me consistent, at least as far as height, because in order to capture that same area, had to kind of be at the same altitude.
Okay.
But yeah, that worked for me.
Did you try any other apps, or, you know, is that the sort of the one that's a good standard now?
I think a lot of people use it. I know I used it in my last extension job before I came here. I think it's, you know, pretty well known within those circles. And as I was saying before, there are some questions about its accuracy, but I know that there are other apps that you can use in, oh man, what's it called? ImageJ, which is an NIH program. If you take a picture and then crop it, there's, you know, different filters you put on the image. But Canopio is nice because it's fast. It immediately gives you that % ground cover, and it works decently well.
Mm-hmm. Great. Thanks very much.
Any other comments, questions? Is there anything in chat? So I have one question, Julia. As I was looking, you know, no matter whether it's pennycress, camelina, or any of these cover crops, this whole idea of how do you get these plants established in corn residue. And as I was looking at your trials, the pictures that you showed, I was just wondering whether it was a residue issue or a planter issue, right? And just looking at your slides, to me, it didn't look like a residue. It looked like seed soil contact issue. Am I reading that right?
So yeah, I think it is a combination of things. We did have some planter issues definitely at the Rosemont site, and I know Russ is on the call now. I think they had a little bit more success in Morris of having less patchy stands and a little bit just more even germination and a little bit better germination that we had at Rosemont. So I think definitely it is a planter issue, but I think that goes along with learning how to treat these seeds that are so small and get them in the ground at the right time using the right depth, along with, you know, other challenges that come along with planting.
Yeah, I know
are-
that's my point, but in the context of researchable questions, that seems to me highlight an area that we really need to investigate is it's the right planting equipment, you know, and the right residue, right? So we just don't. So that clicked into me to think about what type of set of research projects we need to have as follow up to this work. You know, rather than just saying, well, that the residue did it. Well, as you just said, right? It's that combination of residue, but can it be overcome by the appropriate planning equipment? And for me, that is a really important area, not just for these two crops that we're talking about here, but for cover crops in general. You know, as we go into these new tillage practices following, you know, corn. So that just kind of clicked in my mind as I was looking at your slides. I couldn't hear you because I was on this other call, but as I was looking at those, I was thinking, I think that there's a need to kind of sort that through, and I would imagine that the team already is, but that's just what captured my attention.
I was wondering, Don, if along the same lines as if you could just run over that with some kind of mulching system and take that corn stover and turn it into some fine carbon particles that would not be a problem for planting into. Because it seems kind of a shame to take carbon off the soil.
Yeah, I think, but is that Jerry? Jerry, I think, we've been looking at this for years and years and years, and I think that's what these teams are sorting through, is to get an idea that this experiment that she's on is just looking at one possibility. They're certainly looking at other possibilities, including that chopping. But that chopping, you know, still leaves that residue there. So the only point I was making is, even if you chop it, you modify it, I think it opens up this equipment issue that needs to go along with it. And from a research perspective, you know, though all of us online that do agronomic work, getting your hands on the right experimental equipment and getting the funds to purchase that equipment to do these types of studies is really, really problematic, right? So that's one of the weaknesses in a lot of this cover crop work, not just in these projects, but beyond that, is being able to afford to buy the appropriate equipment to run the experiments.
That's your job, Don, just get us the money.
Well, I've been a little successful, but mainly a failure. But just so you guys online know, I mean, these are some of the things that we're looking at federal funds, and this is the case that's being made. So pay attention to some of the arguments that the experiment station directors are making in the context of some of this new federal funding. They're basically laying out the case that this lack of funding for instrumentation and equipment is really holding back a lot of the research in the research institutions across the country. So, you know, we're working aggressively to try to work with Dean Burr and Greg Cuomo, as well as our federal legislators to make that case. Any other comments, questions for Julia? Well, Julia, I appreciate you doing this, and I'm sorry we had these dueling things going on today, but as you know, we'll make sure it gets up, and we'll announce that it's up for viewing. You did a very nice job, as always, so I appreciate it, and the rest of the folks appreciate it very much. So thanks again.
Great. Sounds good. Everybody have a nice rest of your Friday.
All right. See you all in the fall. Bye-bye. Thanks again.
Thanks, Julia.